Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of the Unit B, which is from year 11 chemistry, which we are doing the four forms of matter, which is gases. Today we are doing the temperature and pressure. In the previous lesson, we were talking about the ideal gases and the real gases. It's more like a theory-based concept. Today we are learning about the what is temperature, what is pressure, and how can we go from 1 Celsius to Kelvin in temperature and pressure. We have a lots of pressure SI units, and how can we convert from one unit to another. So we basically doing the unit conversions today, not like more theory one, but we're just doing the definitions of both of them. So what is pressure first? So firstly we have a gas pressure. So gas pressure is a measure of the force exerted by a moving gas molecules per unit area. Gas pressure is that the force exerted by the moving particles. So when the gas molecules are moving and the force they exert on any per unit area is called the gas pressure. So what the gas is, so we have to know about what is gas pressure. So gas pressure is a measure of the force exerted by the moving gas particles molecules per unit area. And atmospheric pressure is from the atmosphere. You can see there the atmospheric pressure over there. So as we are on the low latitude, we are not very we are on the bottom of the hill, we have a higher pressures, we have lots of pressure. But as we're moving up, we get the lower pressure. You can see when you go the uphill or you can go the mountains in the very we have a very low temperatures, you have very on the maximum height, we'll see over there we have a very low pressure over there as compared to the land sea level. So the atmospheric pressure is the force per unit area exerted by the air on all objects. Where the air exerts any force on all the objects of any objects is called the atmospheric pressure. And gas pressure basically up to the gas molecules only, and this is from the air because it's called the atmospheric pressure. So as we're talking about the SI units, so they have SI unit and the non-SI units of the gas pressure. So we have a Pascal. This is the main SI unit for pressure, and we have also have their atmosphere, millimeters of mercury, and a Tolly serial. So these are the unit symbol, and these are like 1 Pascal is equal to 1 Newton per meter square, and we have everything. We for most of the time we use 1 atm and 1 mmHg. Sometimes we use 1 202, but we basically use these two, the atm and the mmHg. So how can we convert from one unit to another? We can see over there. So this is the thing. So convert 100 kPa into the atmospheres and the millimeters of mercury. So basically we are on kPa. So we have the relation of kPa to atm first, because we have a relationship over there. We have relationship over there that 1 atm is equal to 101.325 kPa, which is exactly. So this is the direct relationship. So we can easily convert from kPa to atm first. So how can you do this? So firstly we do it from atm. So what you can do, so we have 100 kPa, we have to multiply it by, so we want a units in atm. So units we want atm, and we have to cut the kPa. So we know that 1 atm is 0.10325 kPa. From here you can see that kPa cancel out, and when you solve this you get the answer in atm. So when you solve this you get about 0.9869, which is approx, and you want 3 sig this. Well, this isn't 3 sig this, so 0.987 atm. So this we convert the 100 kPa into atm. So basically what we'll do, that what value you want, like we want atm near atmosphere, so we put atmosphere up in the numerator and we kPa down, so get kPa cut out, and we divide this and we get the answer. For same with the millimeters of mercury, for this we also have 100 kPa again. So relationship is over there, this one. So this 760 mmHg to 1 atm is equal to this. It also, this 760 mmHg is also equal to this 101.325 kPa too. So this is equal to this, and we have to cut this kPa. So kPa goes to in denominator and this value goes to the numerator. So basically what you have to do, we just do 760 mmHg divided by 101.325 kPa. You cut the kPa, and when you solve now, you get the answer is mmgh. So we get about 750.06 mmHg. You want to integrate this, so we get 7.50 mmHg. So that's the two answer we get when you confirm ATM and FGN, the 100 kp. So that's how you're going to do. In the upcoming lesson, we start doing the laws. So in that laws, we use the pressure as in the formula or equation. And if we have like 2-3 pressures, and all 2-3 pressures should be in the same units. If they're not, first you have to do this work to stay all in the same units, then you have to do another work. So that's why this is a very important lesson to know about this. And save the temperatures. We do the 2 or 3 temperatures. 2 or 3 temperatures should be in the same unit. Basically, we're doing in the Celsius or the Kelvin all the time. So you can be in that units. So doing the temperature. So temperature, every time people can like think about this, temperature is same like the heat. No, temperature and heat is a different thing. So temperature is basically the measure of the average kinetic energy of the particles. The more kinetic energy the particles have, the higher the temperature. So the temperatures always depend on the kinetic energy, the average kinetic energy of the particles. If we have more kinetic energy, the particles have the higher the temperature. But the heat, we're talking about the heat is basically the total kinetic energy, not the average one. It is the total kinetic energy. So that's the main difference between this. Temperature is not like the heat. Temperature and heat is a way different terms. So heat is the total kinetic energy, and temperature is the average kinetic energy. So we have to. Kinetic energy increases, temperature also increases. The absolute temperature scale. We have an absolute temperature scale. The major scale we have a Kelvin. We have a Kelvin temperature scale. So basically, if you see the temperature scale is absolute, you get the temperature over in that absolute scale is in kelvins. Kelvin is a unit for temperature, and Celsius is also the unit for this. It's commonly used in chemistry. So chemistry we can use all commonly the Kelvin chemistry, Kelvin temperature scale, the absolute zero. So when we get the zero, so lowest possible temperature is 0 Kelvin. If we have the like Kelvin temperature scale, our lowest is 0 Kelvin, and in Celsius we have to do in Celsius, so this be the minus 273.15 degrees Celsius. So at this temperature, at this temperature 01, the particles stop moving, because they all depend. If the temperature is lower and lower is 0, so the kinetic energy is not moving any particle now, so particles stop moving. So this is in Kelvin, this is in Celsius. We want that conversion. So absolute temperature is represented by the capital T, and the Celsius temperature is represented by the lowercase letter t. So that's the thing you have to know. So Celsius to Kelvin, if you want to do Celsius to Kelvin, you have to do, this is your Kelvin. So Celsius plus 273.15. From Kelvin to Celsius, do the reverse, do the minus 273.15 with the Celsius or Kelvin. So that's the thing you have to do. So standard temperature and the pressure, which is STP, as I told you have to learn this. So sometimes in the when we do the next lessons, you can see they have mentioned the STP or SATP. That mean in your formula sheet you have these values. That you have to must use this value, that pressure, this is the pressure, and the temperature you have to use this. If they mention STP, if they mention SATP, which is the standard ambient temperature and pressure, so you have to use this 125 degrees Celsius of the temperature and 100 kPa of pressure. I told you how I will tell you how to use this. So this is all in your formula sheet, and if you want to memorize, you can memorize. So these two formulas you have to must be know from the temperature, because we use that frequently in the upcoming lessons now. So basically we have to do two quick examples. So 357 Kelvin into Celsius. So Celsius we have to find. This should be minus by 273.15. So 357 minus 273.15, we get 84 degrees Celsius is the temperature. in Celsius. Now in Celsius to Kelvin, so T is equal to T plus now 27315. So this is equal to 113 degrees Celsius plus this thing, you get about 386 Kelvin. So that's two things you have to do when you do Celsius to Kelvin and Kelvin to Celsius. So this thing and the pressure conversion you have to know now because we use it frequently in the upcoming lessons. So that's all for this lesson. So in the next lesson, we do some volume type thing. So we have used combining volumes. I think you are doing in that thing in grade 10, but we will learn more about this because we do the balancing now. We do have to know the chemistry more and more. So that's all for this lesson. Learn myself where to vibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, like me in the comment section. See you in the next lesson. Till then, stay with EduVibe.